After you've learned all the organic reactions, you might feel confusing to handle huge amount of reagents, conditions, structure of products. I think it may be helpful to analyze and sum up what you've learned. Basically, according to the way of bond-breaking information, there are 4 types of organic reactions, namely addition, elimination, substitution, and condensation. Let's look at them one by one. The first one is substitution. For example, substitution of alkanes by halogens. By definition, substitution happens when an atom or group of atoms in a molecule is replaced by another atom or groups of atoms. Here, a hydrogen atom of methane molecule is replaced by a chlorine atom to give chloromethane. Another example, substitution of haloalkanes by sodium hydroxide. You can see the chloro atom is replaced by the hydroxide to give methanol and sodium chloride. Similarly, for the substitution of alcohol by HX or PX3, the hydroxyl group is replaced by the chlorine atom to give chloromethane. During preparation of unsubstituted amide from carboxylic acid, the hydroxyl group of methanoic acid is replaced by the chloro group when you add PCl3 to it. And then the chloro group is replaced by amino group in the second step when you add ammonia. What you finally get is methanamide. The second type of reaction is addition. Example, addition of alkene by halogen. During addition, atom or groups of atoms add a close and unsaturated CC bond. After addition, you get only one product, no byproduct. Also, the CC double bond or CC triple bond becomes saturated. In this case, you can consider one CC bond and one Br-Br bond broken, and then 2 new C-Br bond formed. What you get is 1,2-dibromoethane. Another example, addition of alkenes by hydrogen. Here, one CC bond broke, one HH bond broke, and 2 CH bond formed. Students, please pay attention to the tetravalency of carbon in the product. It's preserved. It will be a little more tricky when you add an unsymmetric reagent such as HBr to an unsymmetric alkene such as propene. When you look at the propene molecule, the groups of atoms on 2 sides of the CC double bond are different. This alkene is unsymmetric. The unsymmetric HBr can add across the double bond in 2 orientations. Either this orientation or this orientation, resulting in 2 kinds of products, namely 1 bromopropane and 2 bromopropane. Then, which should be the correct product? The answer is both of them. With 2 bromopropane be the major product, while 1 bromopropane be the minor product. Then, how can we predict which is the major product? Markovnikov rule can help us. According to Markovnikov rule, when an unsymmetric reagent adds to an unsymmetric alkene, the major product will be the one with more electronegative atom of a reagent add to a more substituted carbon of a CC double bond. We know that Br is more electronegative than hydrogen in HBr. But what is meant by more substitute carbon in a CC double bond? Let's look at this carbon. Directly bond to 2 hydrogen atoms. All hydrogen atoms are not substituted to alkyl group, while this carbon bond directly to 1 hydrogen atom and 1 alkyl group. One of the hydrogen is substituted by a methyl group. We say that this carbon is more substituted than that carbon. Therefore, Br atom should add to this carbon. you get 2-bromopropane as the major product. When we are talking about halogens as reagent, we mean halogen dissolved in organic solvent. If the reagent used is in aqueous form, such as bromine water, then the product will be totally different. As you can see, when bromine water is added to an propene, we can consider we are adding HOBr across the CC double bond. HOBr is produced when bromine dissolves in water. Again, a more electronegative oxygen will add to a more substitute carbon to give 1-bromopropane 2O. Lastly, addition polymerization is a kind of addition reaction, but this time the monomer ethene undergo addition to each other with breaking of CC bond in an ethene molecule and forming CC double bond with neighboring ethene molecule, all the way on both directions, creating a polymer chain of polyethene. The third type of organic reaction is elimination, a reverse of addition. During addition, unsaturated CC bond becomes saturated. In elimination, CC single bond becomes unsaturated CC double bond. Example, elimination of alcohol to give alkene. CH bond and CO bond broke, a new CC double bond formed, and H and OH is eliminated as water. This reaction is also known as dehydration, which can be brought about by using dehydrating agent such as concentrate sulfuric acid with heating, or concentrate phosphoric acid with heating, or even with aluminum oxide with heating. However, if the structure of alcohol is a bit more complicated, you might get two different alkenes after dehydration, such as this example, dehydration of butane 2O. You'll get but1ene if you eliminate this hydrogen and this OH, or but2ene if you eliminate that hydrogen and that OH. Then, which should be the major product? Usually, a more stable alkene, which is the more substituted alkene, will be the major product. Comparing but1ene, there is only one substitute alkyl group on the CC double bond, while but2ene, there are two. Therefore, but2ene is more stable than but1ene. Another type of reaction that we usually encounter is redox. Normally, a primary alcohol can undergo oxidation by heating with acidified potassium permanganate or potassium dichromate to give aldehyde, and then further oxidation to carboxylic acid. In the structure of a primary alcohol, there is at least two hydrogen atoms bond to the carbon that is attached to hydroxyl group. During oxidation, hydrogen are removed from O and C. The CO bond formed to give an aldehyde. Further oxidation involves adding O to carbon to give carboxylic acid. Oxidation of a secondary alcohol to give ketone. In the structure of a secondary alcohol, there is at least one hydrogen atom bound to the carbon that attached to hydroxyl group. During oxidation, again, H are removed from O and carbon. A CO bond formed to give a ketone. There is no further oxidation of ketone nor tertiary alcohol. The reverse of oxidation is reduction. When we reduce carboxylic acid with lithium aluminum hydride in ether, a primary alcohol resulted. During reduction, CO bond broke, OH group removed, and hydrogen are added to carbon to give primary alcohol. We can reduce a ketone or aldehyde with lithium aluminum hydride in ether or aqueous sodium borohydride to give secondary and primary alcohol respectively. For example, during the reduction of ketone, CO bond broke, and 2 hydrogen are added to carbon and oxygen to give a secondary alcohol. Lastly, we come to condensation. Example is esterification. Esterification happens between carboxyl group and hydroxyl group in the presence of concentrated sulfuric acid and reflux. It is a kind of condensation, means that addition of 2 reagents with the elimination of smaller molecule. In esterification, carboxylic acid combined with alcohol with the elimination of water molecule to give an ester molecule. Bond breaking happens here and here. Water is eliminated. A new CO bond is formed, joining the parent acid and parent alcohol to give an ester with an ester group. The reverse of esterification is hydrolysis of ester. In the presence of concentrated sulfuric acid and reflux, an ester hydrolyzed to their parent acid and parent alcohol. Bond breaking happens here between C and O, the new bond formed that we've talked about. The whole process reversed. H atom and OH group are added back to give parent alcohol and parent acid respectively. Hydrolysis can be catalyzed by acid or alkaline. You have to pay attention to the form of acid that exists in both types of hydrolysis. During the acid-catalyzed hydrolysis, acid exists as free acid, while in base-catalyzed hydrolysis, acid exists as salt form. Similarly, hydrolysis of amide involves CN bond breaking. OH group and H atom are added back to give parent acid and ammonia. Again, during acid-catalyzed hydrolysis, acid exists as free acid, while ammonia in salt form. During base-catalyzed hydrolysis, acid exists as salt form, while ammonia exists as free base.